what we want to do today is developing a front-end application, which is our Android app with Jetpack Compose and all the fancy stuff in Android world, and jump into the blockchain and develop a smart contract with Solidity and all the tools around it to be able to deploy our contract, and then we can connect our Android application to the blockchain. So what is this app is going to do for us with blockchain? It's a voting application. You can vote to a candidate and it register on the blockchain. That's what we are going to do, and getting benefit of a decentralized voting system with the help of blockchain. And yeah, that's what we are going to do. So stay tuned to get to know about smart contract, how to write it with Solidity, how to deploy it, how to make use of Infura to make the connection with the smart contract and the blockchain, Ethereum blockchain, and connecting your application to Metamask to have a wallet and to be able to interact with the smart contract. So many things, but don't worry. I'm going to keep it simple and tell it clearly to you, and you will have a good understanding about that. And if you're into of such topics, you can create your own decentralized application after this video. So stay tuned, get into the code, and happy coding. What I'm going to do to start our work is first explaining to you what is the process and how we are going to implement this project. First, I want to get to Miro and show you my thought process, what I'm going to do. The project I would like to create, I name it Kickstart. This project is about voting football players, the top 10 football players, and there's a voting application which we are responsible to create that, and users can just vote to that candidates. And yeah, that's pretty much it. Let's see what is the building part of this project. The first thing I would like to think of is the front-end application, which is our Android app. And here is our Android application. The next part is a wallet. A user would need to connect the application to the wallet. I would use Metamask for that. So we have our Metamask here, which our Android application would need to get connected to that one. What next is, let's create the smart contract. This will be our smart contract, and our application is going to interact with the smart contract with the help of Metamask and Infura. So these tools are what we are going to need for developing our application and connecting it to blockchain world. And there are some library I'm going to use on the Android project, but I will tell you later on. That's what I'm going to do for this project. But if I want to go a bit more in detail about what functionality, what we are going to have is our application can have a few options, like user can cast their vote, obviously voting button, and we need a list of candidate, and each candidate need to have two parameters. One is their name and the other one is vote, which is a number, the amount of vote the candidate has got. Yeah, that's what we are going to have, and yeah, implement our project based on these informations. So let's start to see how we can proceed. So let's start with Android project, which is a little bit easier to understand and we are more familiar with it. I want to create a new project. The name is Kickoff and the package name. Let's run the application to just see something from this template app. Based on what I said, I want to create some UI state for the application, then user can interact with it. What do we need here now is I would like to keep the project a bit clean and create a style class to handle the UI states and being more manageable with our ViewModel class. So the state class, I would call it vote UI state. And this will be a sealed class, and within this sealed class I would create such few data classes, like, or maybe just a data object for now. I don't know what to put. The first state would be Metamask connect. The next state, it would be candidate list. I might need a success screen when user cast their vote. So, and let's create the ViewModel class as well. So fast forward, I created the UI states and the Jetpack Compose components, and I want to just quickly walk through and tell you what I have done so far. I created a connect wallet screen to connect our Android application to the MetaMask. It's quite simple. It has just a title and a button. That's pretty much it. And the other screen I created is candidate list screen. It get a list of candidates and a click listener to click on the candidate to cast their vote. It's pretty much simple. The intention of this video is not going deep into the Android world and make things so perfect, but I think that's enough for our intention. And the last one is the success screen. It's just a screen with a text and saying vote submitted successfully and a back button. So I also have a main compose component which call it vote screen. In here, for each state I set the relevant screen, and I missed this one, which is success screen with a back button. So I'm going to complete what we need here, like adding a candidate list to the candidate list state and adding these listeners to our ViewModel class to be able to interact with these components. I did some changes for the Android project. Let me show you what has changed. First, let's go to the vote UI state. I added a loading state here, and as I was needed, I added a candidate list to the candidate list vote UI state. And let's get back to the main activity, and these are the screen I created, the new loading and MetaMask connect with the click listener and candidate list. I pass the candidates and have my on candidate selected listener added to this screen, and at the end the success screen, and you can see the preview how it is look like. This is the loading state. Here is the screen to connect to MetaMask, and here you can see the list of candidates, and at the end it's a success screen. I am thinking to add a error state if user is not connected to their wallet, and maybe add a user identity on top of this toolbar to show they are logged in. Yeah, that's what I'm going to do for the final stage of this Android application. And I think after this I will jump into the smart contract and write the smart contract and trying to deploy it on a test network and connecting it with Infura and Metamask and bring everything to our Android project to have an interaction with the smart contract. What I'm going to do is, first, for the IDE, I'm going to use Remix, which is an online IDE, easy to use. I've used it before and I'm more comfortable with it, but it's up to you. If you worked before with blockchain and a smart contract, you can use any other tools, but I prefer the Remix. And this is the work environment is quite straightforward. I go slowly step by step to show you how to write the contract and how to deploy it, and just afterward connecting it to our application. So this is the work environment we have, and within this contract folder I'm going to create a new file. I call it kickoff.sol, and I'm going to write the smart contract with Solidity language. You need to learn it to be able to write the smart contract, but it's not something so difficult. If you know programming languages before, it should be easy to understand. You just need to take a look at the syntax, get familiar with it, and get to know the types they have in the Solidity language, and just write the smart contract with it. Yep, let's just start. First, I have to set the Solidity version. The version I chose is 0.8.0, and starting the contract by contract keyword kick off. That is the start of the work. So what we need here is first defining the candidate data structure. To write a data structure with Solidity keyword and the name is candidate, what we need here is a name and the votes to count the amount of vote for each candidate. After creating the data structure of candidate, I create an array of candidates to put all the candidates I want to be included for this voting. So I need to create a constructor and add those candidates to these candidates array. So I created a constructor block and added those candidates to the candidates array. And the candidates we have for this application are the football players. The top 10 ones, then we can see who will win in this voting. And yeah, that's what we are going to have for the candidates. So let's write some functionality and the logic we want for this voting app. The first thing come to my mind is having a function to return the list of candidates, to show it in our application. So this is the function. I call it get candidates. It's public and just for view. The interactor of contract cannot modify anything, and it returns the array of candidates. That's what we have here. It's quite straightforward. And the main thing we need for this application is a vote function. So let's create the function for voting. At the beginning of this vote function, I need to check if the user has voted already or not. So I need to add a check here if the user is voted or not. So what I need here is mapping of user address and a boolean if they voted or not. So here in this condition, I'm just going to check if the has voted is true or not. To check that, I need to pass the user address, which is from message.sender, and seeing if it's false. And let me add a error message here like you voted already. I think I need another check to see if the candidate index is passed to this vote function. It's not bigger than the array we have in our contract. So to check the candidate index, I am going to make sure the candidate index is smaller than candidates.length we have in our contract, and the error message would be the candidate is not valid. What we are going to do next is first set the has voted to true, and the next thing is registering the vote. So that's it for the smart contract. We created a candidate data structure and we defined some property here to has voted for checking if the user is voted already or not, and a list data structure to have our own candidates, and a function to return the candidates we have registered to show it on our application, and a function to vote. That's pretty much it. And we're going to compile and deploy the smart contract. To compile the smart contract, there is a tab here, Solidity compiler. We go here and we see the contract is already selected, and we just press this compile kickoff.solidity. After compiling the smart contract, if there is no error, it will give you the API and the bytecode for this smart contract. We will need it later when we want to continue on the Android project to be able to interact with these contracts. So we keep this here for now, and we go to the deploy tab to deploy our contract. So to be able to deploy the smart contract to test network, we need to connect the IDE to our wallet. I mean, I am the owner of this decentralized application, and I'm going to deploy the contract to the test network with my own wallet. So here I need to select the injected provider / Metamask. I have already installed the Metamask plugin for the Chrome browser, and yeah, this is my test account, and I have set up the network and everything, and I have a little bit of balance here to be able to deploy the contract. You know that when you want to make a transaction on the blockchain, it gets some fees. It's called gas on Ethereum, and yeah, you need to have some for that. For the test network, you can get it easily on the internet. There are some website can provide those gases for just testing purposes, and here I have a little bit of gas, and the network is Sepolia. So I'm going to do is I already connected the wallet, and I want to press the deploy button. This log was just for the testing. Now let me clear the log and press the deploy. So it says deploying a contract, and I'm going to accept to see if we can deploy our contract to the test network. So as you see, it's a green check, means our transaction is registered on blockchain. And let's take a look at on Etherscan to see the status of the deployment. The status is succeed, and it is deployed. Now the smart contract is ready for interaction. What I'm going to do now is taking some of these data I might have need, the API and the bytecode, to the Android project, and add a Web3 library to Android project and making those connections. So let's get back to the Android Studio to see how we can communicate with the smart contract and the blockchain. So let's back to the Android project. The first thing we need to do, adding a Web3 library. What I'm going to use, it's a library called Web3J. It's just a description here, a lightweight Java and Android library for integration with Ethereum clients. You can take a look at the documentation to see how to work with that, but I made it a bit easier for myself, and since I created the Solidity smart contract within the Remix ID, it gave me the API and the bytecode, and I just copy paste them because needing them in the Android project for building these smart contracts. Before getting to the smart contract, just wanted to show you I added the library in the Gradle file, and then I create a folder here. I call it contracts, and I added just the same smart contract I had in the Remix IDE. I just put it here to have it as a reference, and the API was created on Remix. I pasted in this file kickoff.api, and the binary file in this file. So the only thing I needed to do for the Android project to create an interactor to be able to interact with the smart contract was a terminal command. I just run that, and I wanted to show you the result. This is the terminal command, and as you see, you can find it on Web3J documentation, but what I have set here is just setting the API and the binary file and defining a path to generate the interactor I was talking. And that's the interactor. Let me show you. It's just came here. It's, as you see, is auto-generated code, and it has the functionality we defined in our smart contract, but in Java language, which we can interact with it in our Android project. So that's pretty much it for now to be able to work with Web3J. And yeah, let's continue with the other things we need to do to be able to first connect our application to Metamask to have a valid wallet, and setting up some function to be able to interact with the smart contract. You have to get some tokens from Infura and making those API calls with our smart contract to have those connections. So what I'm going to do now is showing the configuration it needs for the Metamask, Infura, and the smart contract. For that, we need to first set up the Metamask dependency. I added here to the dependency section, and then I went to the Infura website and create an app to give me the API token and use the Sepolia or test network for my decentralized app. I'm going to use this API key in the Android app. One thing else we need in the Android application, having the smart contract address. When we deployed our smart contract to the test network, you see this is the log in Remix IDE and the contract address printed here. Either you can copy from here, or if you are on Etherscan, you can see this is the smart contract address. We will need this to be able to connect to the contract on the Android application. You will see it in a second. So as I showed you before, Web3 created a Java class to be able to interact with the smart contract, which is, as I said before, this is an auto-generated file. I created another file to put all the configuration and data I need to set up for interacting with blockchain. Here, the private key is the private key of my Metamask wallet. You can go to the Metamask application or the Chrome extension and get your private key from there and put it here. I put it in my local properties to not expose any sensitive information, and that's why it is in build config. And the contract address is the address like I just showed you. I got it from the Remix IDE, and just to make it cleaner, I put it in the build config as well. And the gas price and gas limit, we have to put it here to give this to our smart contract class to create a new instance of it. And we needed a credential, which we created from the private key, and Web3 object, and we are going to pass the Infura endpoint, which in this case is sepolia.infura.io. It's a test network, and passing the Infura key. And that's pretty much it for creating an instance of the smart contract. One additional thing we need now is creating an instance of Ethereum object to be able to connect to Metamask wallet. I put everything in a Hilt module, and here you can see I create Ethereum object like this, passing the context and DApp metadata, and you need to pass the name, URL, and icon URL. And we need to pass another option, which is SDK options, and it asks us Infura API key, which we already provided. And I think that's pretty much it. And we can use the Ethereum object in ViewModel class to connect the application to Metamask wallet, and when the application is connected, we can interact with the smart contract. So let's move forward to the ViewModel class and implement this logic. I'm almost done with the project. Let's take a look at the code to see how it has been implemented based on our configuration. Just a reminder, I'm going to this Web3 config again to show you how we initialized an instance of contract. This way of creating contract with credential, we passed our private key from the Metamask wallet. This way of accessing to the smart contract is more for the owner of contract with this kind of credential. But for the normal user, based on my understanding, there another way of creating object, which I will show you here, where I created this object, create the smart contract. I'm creating a client transaction manager. It's a different, based on the documentation, they said this transaction manager implementation for using an Ethereum node to transact. I'm assuming this is the right object to pass to the contract, but this worked so far. Let's move on to the other implementation. First, I am going to tell you about the way of connecting the decentralized app to Metamask. Inject the Ethereum object provided with Health earlier, and I'm using that to connect to the decentralized app. When it connect, it come to this callback. I get the address and then create the contract. As I said, I get the wallet address and passing it to smart contract. This way I create the contract and then I can interact with it. After creating contract, I am going to get the list of candidates from smart contract. The contract.candidates and call the send function to execute the action and get the list of candidates, and I'm passing it to the UI to show it on the UI side. What else about the casting vote? Here is the implementation. Assume we already have the contract object created, and again just call the vote function of contract and passing the candidate index. Yeah, we check here if the status okay. We get the list of candidate again to update our list on the UI. Yeah, handling some errors. So let's run the application to see what we've got so far. So the first screen is the connect with MetaMask. I click on this button and press the unlock in the MetaMask app, and here in the MetaMask app it says this DApp want to connect to your wallet. So we say connect and it connect, and based on our implementation it moved to another state of showing candidate. You remember we add these candidates to Solidity code on the blockchain side, and by calling get candidates we retrieve those data and showing it on our Android application. These numbers on the right side are the amount of votes and the name of candidates and the ballot address, the short form of that, and that's pretty much it. There's a problem I noticed that with casting vote. As you see, when you cast vote it said fail to cast vote. I was looking at the documentation but I couldn't exactly find out the problem where we cast the vote. Here, because we are write something on blockchain and we have to sign a transaction, and I'm not pretty sure if I am passing it a wrong transaction manager or what. For some reason this function doesn't work and it goes to the catch section, but I have to find out how I can make that happen and create a correct smart contract object to make this call as well. But I think I reached to the goal what I was looking for, which was connecting a client application, which in our case which is Android app, to blockchain, and creating the smart contract with Solidity and compiling, deploying, and you get to know all about all this process, and then you were able to connect your app to MetaMask and then connect and interact with the smart contract. And I think we covered a lot. Hope this video has been useful. If you have any questions, just write it down in the comment, or if you found a solution about the issue I faced, just help us to understand and write it down in the comment section. Or I also want to share this code base on GitHub, and I will add the link in the description. You can take a look, or if you want to contribute you can just create a pull request. Thank you for watching. Hope you found it useful. I'm Ali from the Otaku channel, and see you till next video. Bye.